don't do the ones guys.
That's a good picture.
Oh. Have you ever gotten on conference? No. That's what I thought. Have you? Yeah. For what? Wrestling.
Is this a full length picture?
I thought we were like on like conference or like first, second, and all.
Well, because Caleb does really and Caleb Lars. Like if I was at any other way, I would have gotten first. Even like heavyweight. Yeah, probably.
That was a pretty good comeback.
I was angry. You made me angry. Yeah. I'm sorry. I didn't mean to put you on today.
No, just start talking about feet and being really good.
Where is everyone? There are 2 people missing.
Trey and Maria.
Oh, there. Okay, there are. Like, as I felt like we were smaller than usual, but yes, like.
Let's go. We can't break today. They're always the one that rejects.
They definitely
I
don't.
am.
All right.
You're just a voice, and then they always just chime in.
Good. As
Yeah,
we
which
should.
means she should be the one gone.
Yeah, leave.
I'd happily leave. No offense.
I'm sure you're leaving because of them, not because of me.
Yeah.
All right.
And because of this math. Because I can't do this.
Okay, so guys, we're going to set these factors equal to 0. Now, it's x squared plus 1, you could write that twice, so we know there's going to be multiplicity there. So then when I go to solve this, I'm going to move this 1 over, so I can't factor that. So then we're going to take the square root of each side. So the square root of -1, we found that that equals I. And we have plus or minus. But since it's squared in the beginning, that means each of these have a multiplicity of 2. That means it would have, like, we'd have that answer twice, because we'd have up to 4 answers because of the fact that we have 2 times 2 is 4. So there's 1, 2, and then multiplicity of 2.
Oh, so you can like check that.
What's that?
Like if you can like check it back because if it has a multiple.
Yeah, kind of like double checking that there's 4 answers. And the 4 answers, again, we had talked about that before, that it was up to 4 answers, and that was before we talked about imaginary numbers. And so that's where the other answers are kind of like hiding, are typically they're imaginary numbers or there's a multiplicity. So that's kind of what we were missing before that we just hadn't really talked about. All right, so number 9, it gives us some zeros. So it says has the following zeros. So 1 plus I, 1 minus I, -1 and 3. And then it tells us we have the 3 has multiplicity 2, the others have multiplicity of 1. So basically it lists the 3 twice. So it says, what's the degree of P of X? So if there's 1 answer here, 1 here, 1 here, and then 2 here, even though they're imaginary, this would then be degree of 5, right? So that's where that's like how many solutions, and then our degree. And it says write a possible formula in factored form. So that's where you could have left it, I guess, in that factored form. But I did say yesterday that when it's imaginary like that, I'd like you to FOIL it. So we have our P of X, and what we do is it's always X minus whatever the factor is. So we're going to do X minus this.
Wait, why is it always X?
Oh, X minus whatever the 0 is, sorry. We wrote that yesterday, X
When we try
minus.
to factor it?
Well, so when they give you a 0, the factor then, the way you write it is X minus whatever the 0 is. So we're doing X minus this, and so I put that in parentheses to make sure that I distribute everything correctly. Then I'm going to do X minus this one, X minus -1, and then X minus 3, but it's going to happen twice. So this would be considered the factored form. However, the way they wrote it, they did distribute this in to kind of rewrite it a little more nicely. this would be considered factored form. Now yesterday I did mention that we should FOIL this, and so just to review that a little bit, I'll do that now, and I wrote it up on the board over there, but we can FOIL it. Now, we'll talk about this more today, but anytime we FOIL something that kind of looks like this, it's typical that the eyes are going to drop out if they're that similar, and I'll tell you guys more about that in a little bit today. So we're going to do FOIL, so I'm going to multiply this x times all three of those, and I'm going to change up colors here just so we can see what's going on. So this is getting multiplied to all three of those. So that's the first three. Then I'm going to go and do the next three. Then I'm going to do the I times everything, or that negative I times everything. Now, when we do this, a bunch of this will cancel. So if you look, IX, they're negative and a positive, those cancel. Then I have a negative I and a positive I, those cancel. Then I have I squared over here, remember that equals -1. So I'm going to combine some like terms here. So I have x squared, negative x is a negative 2x. I have 1, but then this is also 1. And so that's how it FOILs to be x squared minus 2x plus 2. And we'll practice this a little bit more today. I know that makes you really excited for what we're doing, but we will be doing some FOIL with that more today. So if that went poorly, we'll review it a little bit. All right, then number 10, it says, it gives us the fact that 2 is a 0 with multiplicity of 2. So a 0. So they're telling us x equals 2 is a 0 with multiplicity 2. So we'll use that in a second. If it's a 0, I can use that using synthetic division to kind of factor that out of this. So I'm going to write my coefficients. And there's no missing powers of x. That should be good. And I know yesterday, Trey had asked me about this one, and I kind of shouted something out about it. But if you didn't hear us, we were talking about the fact that he got to this point, and he was left with what we have here, which is this c, this is x squared, this is x to the third. So what he's left with, or what you guys were also left with, is this. And this is not factorable. Like if you try to factor something, it's not good. So the fact that it's multiplicity of 2 means I can do this all again with my new, my other 2, since it happens twice. So I'm going to do 2 again because of the fact that it's twice here. So there's our remainder of 0. So what we're left with now, here's our constant, here's our x squared. All right, now this is not factorable, but this type of problem, we know how to use quadratic formula to help us with this. So we're going to take this and now do quadratic formula. So this does become a long problem. And I'll flip the page because I won't have enough space, but we're going to do the quadratic formula using this, because we need to still find the other zeros, because nothing multiplies to give us positive 6, but adds to give us a negative 2. So, quadratic formula. We use the opposite of b, which, so a is 1, b is negative 2, that should be a negative 2, and then c is 6. So opposite of b is 2 plus or minus the square root b squared minus 4ac all over 2 times a. So I get 4 minus 24, which is a negative 20. I'm going to pull that I out of there because of that negative 20. However, square root of 20 can be simplified. What goes into the square root of 20? Yep, 5 and 4. So I'm going to break this up. Square root of 4 is 2. Well, I'm going to write that as 2i. So at this point, if this is a, like if you got to, like really this whole last line, you're doing pretty well. You just need to kind of review this simplifying. So the 4 becomes a 2, that pulls out. All of these can be divided by 2. So I basically can cancel all those 2s. So I'm left with 1 plus or minus I square roots of 5. Because 2 over 2 is 1. So that is my final 0, which is one that wouldn't show up like on a graph because it's imaginary. So that makes it a little bit tricky to find. And we will practice quadratic formula a little bit more today. Yeah.
So like, what is that? Is that like a factor or?
So that was those were 2 more zeros.
Oh. Okay.
So remember we had 2 zeros, the 2's with multiplicity of 2. So 2 and 2, and then those are 2 more zeros. And if we go back and look, that makes sense because of x to the 4th. So we should have 4 answers. And so we have them all. So we have 2 and 2, and then the 2 imaginary zeros. Okay. Questions there? All right. Like I said, today's going to seem really similar to yesterday, and maybe not the worst thing in the world. We're going to add just a little bit of extra to this. Now, just a reminder, today we do not have AR because of Ramway. So, but we normally wouldn't have ARs on Wednesdays anyhow.
Can we check into AR and
Oh, good question.
What is that? Just like a monthly assembly?
It's like it's a fun assembly. Hopefully.
usually they're not very Macy's own brand.
We should just have like a fun day soon. I feel like we've all been working pretty hard.
Today.
Yeah,
Right now. Fun day. Kahoot.
We could probably do a fun Kahoot as a break here.
Hey! Wait, I don't think we've done Kahoot like all year.
Oh, there you go.
We did
There you
like
go.
It messed me up. It messed me up.
Yeah, because I have 2 weeks. I have 2 weeks.
Alright, so the warm-up question you guys is asking to solve that, and it's not factorable. So you're probably gonna have to do quadratic formula.
You don't even think about it. That's the only thing that sucks about us. No one does it.
You literally don't even try to practice.
We can keep doing.
And it's fun though.
Are you not wrestling this year?
No, but
I didn't quit, I just didn't join
Like
again.
a bum.
he went out. That's why we were talking about breakfast with your coach, because then Matt
Oh.
took him to breakfast and tried to convince him to.
Oh.
But even though Matt like bought him a nice meal and like gave him like his life savings, he still doesn't want to check us.
That's illegal.
So if someone buys him breakfast, he should do whatever they.
Yeah.
That's what's.
How do you know? That could have been his last bit of money. He was gonna spend that on rent. Now he doesn't have a house. And you just don't even
Pretty sure they're fine.
Yeah, that's what it seems like. But how do you? We're learning in personal finance right now that not everything is what it seems.
Yeah, I took personal finance.
Then you should know.
I do know.
Alright, is this one factorable?
Yes. Yes, it is.
Want it to be. Are you guys still okay with just knowing this formula versus talking about
Yep.
completing the square? Okay, so.
Hey, no, I'm not ready.
Here, we just started.
I'm already done.
This is tiring.
This is tiring, you're already tired.
I'm already done.
What's 8 squared? 64.
We just asked for
What's that say? I thought I answered my own question, so I feel like I can't.
He was just thinking out loud.
Yeah. Come on, respect the grind.
No.
He's trying his best to back up. I'm like, did you even start?
I finished.
Yeah, okay. Nice
Here, you
try.
didn't even start.
That's because I'm struggling. God. He's trying his hardest.
Really? Is he? You didn't
Don't
tell
make
me.
fun.
I did. She said, is this factorable? And I said yes.
It's not even factor.
Yeah, I know. That's because we did it wrong.
You didn't even do it.
Yeah, because I thought it was factorable.
Alright, so.
She literally said before that we
Who
started
puts a
solving
problem like
this.
this and not make it factorable?
She literally said before we started solving this that it was not going to be factorable.
That could.
You suck. You know that's coming out.
Yeah, shut up.
Is this
Okay, we're ready now.
Let's go.
We can move on.
Alright, so quadratic formula. So our A, B, and C, we're going to put all that into our formula. Opposite of B, plus or minus the square root, B squared, minus 4 times A times C, all over 2 times A. So, when we go to now square negative 8, it's going to be 64. And then this is going to be minus 100 all over 2. Now 64 minus 100 is going to be a negative 36. And they don't always, obviously, this one even works out nicely because it is a perfect square. Sometimes these numbers are just like the square root of negative, I don't know, 7. You know, like there's times that it's just going to be kind of awful and you kind of leave it with a square root and that's okay. This one works out nicely in terms of imaginary numbers because the square root of negative 36 is going to be 6i.
You wouldn't give us a tough one like that.
Probably not on like a, because no, probably not.
Okay.
Unless I made a mistake. Sometimes I type wrong.
Unless you're feeling devious.
Is this a tough one?
No.
What is that?
This is easy.
I'd say this one works out pretty nicely. All right, so we're dividing each of those by 2. So those are our solutions, and it makes sense that there's only 2 because of the second power. They just both happen to be imaginary solutions.
Way to be so. Very proud of
All right. We will kind of come back to this warm-up question a little bit later in terms of talking about the zeros of the function. So kind of hang on to that. We're going to talk about the conjugate. We had talked about conjugates before. I always think conjugates sound like a disease, conjunctivitis or something. So what the conjugate is, we had talked about conjugates when we were trying to get rid of the I. So basically, just to kind of quickly summarize what a conjugate is before I tell you this rule, is so it's exactly the same terms, but the opposite signs. Those would be conjugates. Now, it doesn't have to be an I, it could be an X, it could be anything, just basically the same two terms, and the opposite signs are considered conjugates. So, what this conjugate zero theorem tells us is that if we're talking about a polynomial, and one of the conjugates is a zero, the other one is automatically going to be a zero. So if we're dealing with, we have some polynomial, we'll call that P of X, that's a polynomial. Now this is something you'll hear a lot in this second section. It says if a polynomial has real coefficients, we're only going to deal, or mostly are going to deal with real coefficients. So that means all the numbers in front of the variables are going to be real numbers, so not imaginary. So when we talk about real numbers, we're just talking about non-imaginary ones. So if we have a polynomial with real coefficients, so just your normal run-of-the-mill polynomial, and one of the conjugates is a zero. And let me see how they wrote it, yeah. So if the imaginary number is a zero, then its conjugate is also going to be a zero. Now, we didn't, like, this technically happened yesterday, but we didn't talk about it, or we hadn't mentioned it at all, or like said that it was a rule. But so if an imaginary number is a zero, then its conjugate is also going to be a zero. How we're going to look at that is this first example here. There's not a lot of space because you don't need a lot of work for it. So it says two of the zeros of this long polynomial are 2 minus I and then 2I. It says find the remaining zeros. How many zeros should we have in this first example? We should have 4 zeros because of the fourth power. Now if they give us 2 of the zeros already and they're imaginary, we can then assume their conjugates are also going to be zeros. So what's the conjugate of 2 minus I? 2 plus I. Now the other conjugate's a little bit strange, but
2 divided
what's that? So basically the conjugate is like the mathematical opposite. So it's just going to be a negative 2I. Now, if that's confusing to you, I'll show you kind of why that is.
I actually. Why do we have to go out and do that? Like, you gotta pretend like you didn't get it.
All right. So, just to kind of see how Becca knew that, or kind of the why behind it, why that, yeah. So, do you agree that 0 plus 2I is the same as 2I? 0 plus 2I, 2I, yeah. So the conjugate then would be 0 minus 2I. We just don't write the zeros just because we don't need them. So it's just kind of understand that conjugate with imaginary numbers. It's new to you guys, so it's okay. It's okay. Alright. Alright, my computer's freaking out on me here for a second.